All right. Question number 18 out of your book asks us about a buffer solution. It's 1.3 molar sodium phenolate and 1.2 molar phenol. We haven't talked much about these substances. Um, that's okay, because it's just an acid-base pair. This is our acid. And this is our phenolate, which is our base. So if you read the problem carefully, you're given the pKa of phenol, the acid form, and you're told the concentration of the base and the acid, aren't you? Which one's the base? Well, this ATE ending. Remember that ATE ending that I told you about? That should be a clear indicator that stuff is the base, okay? That ATE ending is very often used for the conjugate base. So how do we solve this problem? Well, it's pretty easy. We know it's a buffered solution, and we know we can compute the pKa, or the pH of buffered solution, by using Henderson-Hasselbalch equation. So all we need to do is plug and chug. We're good to go. We need the molarity of the base, we need the molarity of the acid, and we need the pKa of the acid. Now if we look carefully at all this problem, we're told the pKa of phenol is 10. Plug that in. We're also told the pH buffer has a 1.3 molar sodium phenolate concentration. That's our base. So I plug in a 1.3 for that. That's my molarity of the base. I need a molarity of my acid form. I'm pretty sure that's given in the problem, isn't it? It's 1.2 moles per liter. So if I take this ratio out here on the far right, I do 1.3 divided by 1.2, and I get 1.083 as that ratio. Now I need to take the log of that ratio. So I do log 1.08333, repeating. I get 0.03476 on my calculator. I need to add that to 10, and that's my answer. So the pH of this buffered solution is 10.03476. I'm not paying attention to sig figs here, but that is the pH of this buffer. Very close to the pKa. The reason why that is because there's only a slight imbalance between the concentration of the acid and the base. Does my result make sense? Well, the pH is slightly above the pKa. It's slightly more basic, and that does make sense, because isn't the concentration of the base larger than the concentration of the acid? It is. So all this makes sense, and I'm comfortable and confident we got the right answer. You'll probably see one like this on the exam. It's really kind of user-friendly. It's just plug and chug, Henderson-Hasselbalch equation. So when you see that, hopefully everybody gets it right. All right, this one's not too hard.